Now, one of the equations we can use for quantitative risk analysis is this thing we call the annual loss expectancy, or the ALE, if you like. Now, the approach of this is to simplify the assignment of a value of probability in a way that's easier to quantify. You know, I like the way they word things, right? You're thinking, okay, what does that really mean? Okay, what it does is an equation that's going to look at the value of an asset. So let's do my building. As I said before, I've got a building, and we're going to make it worth $2 million. Notice I'm using nice, easy numbers because I don't want to do hardcore math. And you're not necessarily going to be asked to do the math equations on the exam, but to understand the concept of what they're doing. So that's what I'm trying to get across here. All right, now we also have to know what are the probabilities of the event occurring. All right, so we're going to talk about tornado damages, right? All right, so over here I'm going to say, all right, well, you know, I was just talking about tornadoes, and we know that it'll occur once out of every 10 years. And so the probability of a tornado, and by the way, this isn't fair. I'm really over-exaggerating. Just because there is a tornado doesn't mean that it's going to seek and destroy your building because it has a grudge. But, you know, I'm doing this for the purposes of illustrating. It would probably be more likely to say, how often has a tornado ever damaged this particular portion of the city that you're in? And that may have never occurred. So, you know, so it has a less frequency. But I'm just having fun with these numbers. Anyway, that 1 out of every 10 years means that every year we have a 10% chance, right, 0.10, 10% chance that it occurs. So that's the probability of the event occurring, and the single loss expectancy. So what we've decided that is if the tornado hits, that the SLE is going to be 25% of your building is destroyed, okay? So we know that there's 25% damage. So actually, I moved that little number over here so I can do that multiplication. And if I am doing my math right, we know that if the tornado hits us, it's going to cost about $500,000 in damage. All right, so that's great. You know, we've got this idea. All right, so now the thing is that is the single loss expectancy. We know that the average rate of occurrence. That was this probability of the event over here, right? This little thing, average rate of occurrence, was 10%. So that's 0.1, I guess. So we know that annually we might expect that if you were to say, okay, in 10 years we're going to get hit by a tornado, it's going to do $500,000 damage. If I divide that damage out over 10 years' time, I know that I'm going to be basically thinking about $50,000 a year in potential loss. Well, that's what this is. That's what we call the annual loss expectancy. Now, what can you do about that? Well, you know, I'm not a construction engineer, but you might think about improvements to the building, securing foundations, better design, you know, all sorts of things you can do. That would the goal would be to try to lower that single loss expectancy down to a lower number, so you can have a lower annualized loss expectancy, because I don't think you're going to do much to convince nature to not send you a tornado, but you can try to prepare better. Anyway, that's what we look at when we talk about these equations with this quantitative risk analysis and what it means to talk about the annual loss expectancy.